right, greetings everyone, and welcome to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in this episode we are continuing on with our Python programming series that we've been working so diligently on. Back in the studio with us today is none other than our resident expert, Mr. Justin Dennison. Justin, welcome back to the show, sir. How you doing?
Thanks for having me back. I'm doing very well, and we're making those steps closer and closer and closer to that final kind of culmination of all of these skills we've acquired. So we've been using some of these standard library functions like len and print, even though print in 2.7 is not really a function. The max function, the min function, the sum function, those are standard built-ins that I have access to right off the bat. And let's just quickly review a couple of those and see how those work. But there are a bunch of other standard library functions, but I have to do some special things, and we need to get that last little piece of the puzzle before we can start putting all of this together. So
without further ado,
here we go. So if we take a look, I have just a list of numbers, a list of some strings, a string dictionary that has a mapping, and then a tuple. Right. So if I were to just remind myself, what does len do? Well, if I run that, maybe I get 4. Okay, awesome. What does max do? These are pretty self-explanatory, but it's always good to have a quick review. It just so happens that the 4 is also
the fourth.
Yeah, the 4th. So just to keep from having confusion, my tuple, the maximum is 5, and then I can do min. And I can actually say, okay, I want to print out dir, which gives me all of those list of things. And as we've seen in the last couple of episodes, this can be very nice to have, but it can also lead to some points where you're like, I don't really know what this part does, and that's okay. But I do get some, hey, there's a count, there's an index, and that's about all we need to worry about for tuples. So these are some built-in functions. Remember, I'm treating print as a function, but in 2.7, print is not technically a function that it behaves like it, but it's a special statement. So we have to be careful. We can't use it necessarily in the context that we always could a function. I've written it in the Python 3 variety to simulate that, because in 3 it is actually a standard library function.
So Justin, when you say standard library, what you're telling me is that there are all these functions built into Python that are part of the standard library of functionality that make up Python, and I can use them anytime I want because I don't have to reinvent the wheel. They've already found some very common ways in which you're going to use them, or people were creating common functions, and they said, you know what, let's just add that to Python, make it part of that library so they can call upon that and do a whole lot less coding. But we've only seen a few of them, right? There's a myriad of others.
Yeah, it's when I look at the standard library list of functionality, like all the modules, as I've told you, you will go, I wonder if I could do X, Y, or Z. And you start hitting the interwebs, and you're like, wow, that's built in. It's almost like that scene where you look at the Holy Grail and you go, oh, it's so beautiful. That's kind of how I feel when I look at the standard library. Except we have to treat these a little differently. These don't always come imported in. I can't immediately use these upon initial programming, because otherwise my program files would be huge. So Python provides us a way to import these in a variety of manners, so I can only grab the little chunks that I need from each one. So I think a good place to start is, how do I do that? How do I bring in these pieces of the standard library that are called modules? So these modules are a bunch of functions bundled together that I can bring in and use. How do I bring those in? Well, I can say import, and there's actually a math function. So math provides an expanded use, like exponents, gamma functions, which if you've done any scientific stuff, the gamma function, you're like, cool, I know what he's talking about. If you don't, it's totally fine. I know how people get scared with math. Ceiling, floor, square root, I think you can do average.
I'm about to fall into the fetal position. and
Yeah,
set my
yeah,
thumb
you-
because this is getting scary.
Yeah, so we're just going to look at a couple of them and actually look at a new number type in comparison with these, what are called floats, floating point numbers, decimals. We saw those a little bit. I tend to stay toward integers because they don't behave weirdly. But if I import math, I now have access to the math set of functionality. So in this episode, we're going to go through a couple of these that are really, really valuable, that I use all of the time, and provide that power to start doing some of that system stuff that I find very interesting, and I know that you do as well. So if I import math, let's go ahead and let's keep this. Okay, so I'm just going to use these. So if I want to use the functions from the math module, I need to math, and then I have to put a dot, right? And then since I have some auto completion here, so I won't save that until I have to. I have some auto completion. Here's all of these math functions that I now have access to, and careful, Daniel. I know you're like, I don't even know what these do. That's okay. Some of them I don't know what they do either, but that's perfectly fine. I have access to pi. Everybody loves pi. But one that I use is ceiling. Like, take this 2.5 and go up to the next largest number. So if I do math.ceil and 2.5, well, print math.ceiling of 2.5, and what does that in fact do? It rounds up to 3. But what do you notice that's different about this number?
It has a decimal point.
It does have a decimal point, and these are called floating point numbers. I can use decimals. They behave a little bit differently than ints, and let's just hop over to the shell real quick to illustrate that. If I did 3.0 divided by 2, I actually get normal, what we would call normal division. So anytime I have a decimal in one of the numbers, I get kind of that normal division. So if you want to keep normal math operations working for you, then just add a .0, or make sure that one of them is what's called a floating point number. So that's good to know, because this math module provides access that a lot of times will come back as floating point numbers. So this comes back as a floating point number. What about math.floor? Well, I like the name of this because if the ceiling goes up, I wonder what the floor does.
It goes up even higher.
You know, Daniel, you were making me happy, and then no, I know what you're saying. It's the next story up.
That's it. It's the floor, right?
It's the floor, which is past the ceiling. Let's see what it does. It actually effectively rounds down. It truncates, gets rid of all of the decimals down to the next whole number.
Right. So it helps you work with whole numbers. If you have a decimal number or one of these floating point numbers that you're working with, you're like, you know what? I want to make it quick. I want to make it easy. I'm sick of all this this guessing game here because I'm not great at math. Just make them whole numbers so it's easier for me to work with. We can use the ceiling and the floor to make that happen.
Right. And then if we really wanted to put them back to those integer values, we could just say, hey, make those back to integers also. So this is a way that we could round. So, you know, the math module's nice. It also comes with square root, right? If you're doing some calculations, you need square root. So math dot square root of 4, we know what that should be 2. If we run that, I do in fact get 2. But notice I imported this math module and I couldn't just call ceiling. I just couldn't call ceiling from math. I had to say math.ceiling. This is something called a namespace. So I can namespace these modules, because what if I had a function called ceil, right? If I had math.ceil versus ceil, I could have what's called a namespace clash, or a function clash, where it goes, I don't know what you want me to do. I have two things named ceil, and you know, one of them is just prints look up, and the other one actually operates on numbers, and I'm trying to figure out, I'm having trouble. So this importing modules provides a way to tease those apart. So, you know, upon this, some of these modules have very long names. Math is not one of them, but I can actually change how it's referenced. If I import math like this, I import the entire math module, and it's just math.ceiling, math.square root, math.floor, but I can also say as m, and to say I want to call everything that's in math just by m. And then I can go m, and I get the exact same output. So this is a way to change some of the standard Python functionality and name it the way that you would, you kind of think about it, that makes sense to you.
Now, Justin, what's the advantage of changing it from math to M?
The advantage is sometimes these libraries, let's just run through one of these. Here's one, argv emulator, right? Let's say I'm using the argv emulator module.
As you normally would.
Yeah, I mean, I use it on a daily basis. I don't want to type argv emulator dot every time. So maybe I say import argv emulator as, so let's just do that, as remu, or maybe even just emu, right? And then anything that I want to use there is just emu dot instead of argv emulator.
So it essentially helps you to basically abbreviate maybe and lower the amount of typing that you have to do in your code, cleaning it up, make it easier to read, and giving it that that nicer look to it, and making, I guess, just easier to read and work with.
Right, and then another quick example, sometimes it makes more sense to you. Python comes with a base HTTP server, so I can just say as HTTP, because then it interacts with HTTP protocols, or I may even just call it server, and then I'm like, okay, this is actually a server, but I know it's HTTP. In addition to this, offers power to you that if you're using third-party modules, which you can go download and integrate, I can just switch these out, change this name, as long as the functions are still the same, and then all the rest of my code is already done. So if I use an alias, and I have these modules that are interchangeable, I just change one line of code, and it still works just like it did before. Maybe it's a little more efficient, maybe it's faster, maybe it provides additional functions other than the core functionality. Like for instance, if I wanted to, there's a server framework called Tornado. If I wanted to now use Tornado as my server, I just switch out the Tornado part, and hopefully everything still works. There may be some minor tweaks that you have to do.
Gotcha, yeah, that's extremely convenient to be able, instead of having to go through the entirety of your code, and yeah, we do have cool find and replace features on most of our editors. All you got to do is run up to wherever it is you're trying to call that module from, change what it is you're calling it to, and now everything that, like if you had Tornado and server, we want to change it back to the HTTP server, just change the HTTP server. Now everything that says server is the HTTP server instead of Tornado, right?
Right, exactly. So it's very handy, and you'll notice in the community that these follow a fair amount of conventions. Some of the third-party libraries you'll see are like, always import this way. And then there's one final import way that we need to look at, but I think it's better to, I hinted, Daniel, that you really like some system things, using bash, some of these commands like rm-rf or rm, some file name, or touch some file name, or make dir. Well, I've got a surprise for you, Daniel. Python has all of those built in. They are standard functions within the standard library.
Wow, you just gave me Christmas and my birthday all rolled into one there, Justin.
I know. I got excited when I learned how to use these, and I was like, oh, because now I can just call those functions programmatically, and we're all good to go.
So that's awesome. So you're telling me, just like in Bash, where I can say, here is a directory, right? I want you to look inside the directory, and I want you to remove star.star, right? And it will do that. I don't have to do anything special to make that happen.
So the programming interface is a little different than some of these standard Bash scripts, but all of the functionality is still there. And typically, they have very similar names. I think it's best to maybe just take a look at a few, but introduce some new syntax. Let's say I'm writing a system admin script, right? I need to walk through a directory. I'm going to, this is the final import style, from OS, import, and let's import a favorite of mine, walk. So now instead of having to type os-walk, I can just type walk. So I'm going to come down here. I'm going to actually comment all of this out So I want to walk. What's a good directory that typically has some interesting stuff in it? Not too much.
Not too much. Okay, let's try. Etsy's are usually a good one. etc.
Etsy's usually a pretty good one. So print, and there we go. Let's see what this does. So generator. So Walk will actually give me a thing that's a giant collection of all of these functions. So what do I want to do? Well, anytime I see generator for our intents and purposes, write a for loop. For item in Walk Etsy print item. And not as pretty on the command line, but it'll actually give me every possible combination of files, paths, and folders in the Etsy subfolder. So it says Etsy, and then here's a bunch of files that come in Etsy. Here's a bunch of configuration, or excuse me, these are folders that are in Etsy. And then if I scroll down a little bit, it says inside of Apache 2, there's all of these things.
So it's completely recursive. It goes through every single thing.
Yeah, I just find these.
Wow.
Yeah. So this would be a great way to go. I just need to look through everything on my computer and find every configuration file that exists and do something with it, right? Add a new little log. So this is a great way. So this will give you the base directory where it looked, what are other directories in it, and then another list of all of the files that are in that directory also.
Very cool.
So the walk function is great. But there's also some other ones. I know a common one I use is to just make new files. Makedir actually is a Python function. I don't know what you call it. I call it makedir.
That's what I say, makedir.
Makedir. It helps me. I'm like make directory. So if I say from this directory, I'm going to make dir, right? And within where I am, where the script executes, I'm going to have a new folder. Let's just call it test folder. And ls, and right there it is. So now I can just run through and automate all of these makedir processes, and it works very similar to makedir like I would normally use it.
Yeah, that's very awesome. I can see where that could be very functional for maybe creating an old, like a backup file, right? I want to take a backup of a certain directory. Well, maybe my backup directory doesn't exist, and I want to copy it to something. Maybe I give it some input and say, this is the directory I want you to make a backup of. Then it will look that up, say, well, you don't have the directory I need. I'm going to go ahead and make that. I'm going to copy all these files, dump the output as .bax, and now you have a backup file of all that. Now I can clean up the original directory, make it nice and clean for you, nothing inside of it. You can go back to saving new files there, and you got all your old stuff and a backup file in a different location. That would be very, very helpful.
Yep. And you know, one of the downfalls of makedir that I found is when I want to make, I'm like, okay, I know where I need to make this, but I need to nest some folders. You know, there's that -p flag that I can add to recursively make those folders. Well, Python also provides that by saying I want to make dirs, and then you can give it a series of path names. So within this directory, I want to make a folder and then an inside folder. And this will actually, if this folder doesn't exist right now, I hop over here, it doesn't exist, test folder does. But if I run this, oh, forgot. If you already make it, you can't make it again.
Remake it again.
Yeah,
That's right.
so that's a standard functionality. So I have folder, and inside a folder, I have an inside folder. So I can give it a long path, make dirs, and it'll make all of those things at one time with a single function call, which we can do in Bash, but I find this pretty helpful when I'm like, okay, I need to make some folders here, move these things around, come back out. It's wonderful, wonderful for me. Great.
Awesome. What else can we do in the OS using Python?
Well, what are some other common things that you use on the terminal?
Let's see here. I probably copying files is a very common thing that you do.
Okay, so I mean, we could open a file, copy. So how would we copy? Copy. I don't know. Maybe copy. That's a
Copy just very well may work, huh?
It very well may work. Let's find it out. And what's a good way? I could just hop into the shell right here and say import OS and then dir OS and take a look. And copy. It doesn't look like copy's there.
Do they have CP?
CP, it doesn't look like
Yeah.
CP's there. So,
I guess in Linux systems, typically, if you want to copy a file, you'll actually you'll move it, if I'm not mistaken.
You'll move it.
We'll actually just do an MV, move from one file from the other, and it'll. If I'm remembering that correctly, there's always one way in which to do it to copy, because you're right. Copy command. I thought CP was it, but maybe it's not.
CP does actually work in the terminal, but I'm glad you brought this up. Not everything is there, and the reason being is I could simulate a copy by reading in the file and writing out the file in a different location. So I could make my own copy. So that's typically not in there, but some of the more things, chdir, that's not something we see in Linux. That's not something we see on the command prompt, but it is something that you and I have used. So if I change dir, and I can say change dir, and where do you want to go? I want to go inside a folder. And then there's another one that's great to see, and list dir. So this will actually give me a list of all of the things within a directory. And unlike walk, it doesn't give me necessarily recursively, it just gives me that top level, which is sometimes all I need. So I'm going to comment this out because those are already made. We'll get an error there. So change dir, I want to change into the folder, and then I want a list of all of the things, and I'm going to go ahead and print that out. Whew, that was a lot of stuff there. So if I run this, oh yeah, I need
You
to.
might be already in that folder.
Yeah, I'm actually in that folder. So from when this script runs, I'm actually going to go into this folder, run list_dir, and print out all those things. Uh-oh, unexpected indent.
The indents will get you every time.
And where did it happen? Line 4. Oh, I am silly. Let's try that again.
Uno mas.
Trailing comma not allowed without surrounding parentheses. So we've run into a problem. I wanted to wrap this around. Let's make sure I'm not doing anything else wrong. No such file or directory. Change dir. Folder. Oh, do I need this leading slash?
I was about to say, you might have to give it the full path.
There we go.
Yeah.
Yeah, so I don't, sometimes the leading slash, if I wanted that, I would actually probably do that.
Yeah.
So be careful with those. And those are some of the nuances that would kind of happen within the terminal. So
Easily fixed. If you know anything about the operating systems you're working with, you're going to see the error and you're going to go, okay, what's happening here? Okay, I see what's happening. I need to remove something or I need to add something so that it knows exactly where I want to go. I tend to use full path names just to try to avoid situations like that.
Yeah, but if you're making effectively like a crawler, sometimes that gets a little weird because you're automating some processes and you're like, I know I want to go in this folder, look at everything around, find these things, back up. But if you ever need to check, there's actually another function that is great. And this will probably finish up. If I want to print get CWD, just run it as a function. Where'd you go? Oh, I didn't save. A common mistake that people will make. It will actually give me the full path of where I am at that current time during the script execution. So if you want those full paths, you can actually use what get CWD, which would work like PWD on the Linux terminal.
Very cool.
So I've made all these dirs, right? These directories. I finally want to clean them up. There is a way to remove files and directories. So I'm going to bring in remove and remove dir. So instead of going into this directory, I'm going to comment that out and remove dir, and I want to remove folder, right? So folder directory not empty. This is a common error that you will see. So what do I need to do? Well, this actually brings us to an interesting point. In Bash, I could just stream these, right? Remove everything that's star.star. Typically in Python, you're going to have to iterate through all of those things. So I could do something like this. If I go into that folder, I could say for folder in list_dir or for thing in list_dir. I could just say remove dir, and I know those are all directories. I could test for that. Remove thing, and let's see if we get invalid syntax. Oh, that's because I have an extra parenthesis here.
They looked so good.
They do, they do. And if I ls, folder's still there, but there's nothing inside a folder now. So I can kind of crawl through those. Some of the stream things, the multiple arguments, don't work quite like the same, but it's usually easy to get around if you've had some experience with your operating system.
Yeah, and it keeps you from having to jump platforms, right? What's the point of writing all these bash scripts that do certain things and then try to have them work with your Python scripts? Just, if you're in Python, you know how to use Python, use Python. It has the ability to do all these things for you within itself, so it just doesn't make sense to try to, like I said, cross-platform.
And one of the great things about Python is if I write this and I'm running it on a Linux system, it uses kind of those OS processes. If I go to Windows-based systems, I will actually get like C:// those path names instead of a Linux-style path names. But then remove dir would still remove folders, or remove would still remove files.
Yeah, that's cool. So it gives you like a standard set of commands across OS platform.
It does, it does. And luckily, Daniel, with these tools, the tools that we've seen before, we're right on the precipice of some interesting things. Well, I think it's interesting. I hope you think it's interesting. I hope everybody else thinks it's interesting. But I think that'll do it for kind of our OS and import, how we use these standard library functions.
Well, excellent. I cannot wait to see how this all culminates into our final product, being able to take everything that we've learned and actually create something awesome out of that. Justin, thank you for joining us today and explaining how we can use Python to work inside of our operating systems and play around with the cool modules that are built into the standard library as well. That being said, looks like we've wrapped up yet another great episode. Hopefully you guys enjoyed it and learned something from it. Signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Justin Dennison.
And we'll see you next time.